let's try recording. Andrew, can you hear me okay now?
Yeah, I can hear you.
Okay, great. Okay, welcome everybody. So welcome back to in-person learning, or at least the next while. Hopefully this is like the way it'll be for the rest of the semester. Nice to see everyone in 3 dimensions. So today we're going to talk about, so actually, are you happy to be back? Are you sad? You're like, no, I hate the commute. I wanted to live in my basement my whole life. Actually, my eldest daughter kind of like, she hates commuting to school now. Online learning has taught her to hate commutes. So who's happy to be back? Okay, who's not happy to be back? A few, okay. And the rest, I guess, are ambivalent. You're fine, you go with the flow. Okay, so we're going to talk today about debugging. And debugging is a really key skill. Okay, so why is it such a key skill? Well, because programs, basically any complicated system doesn't work at first. There are going to be bugs. Basically, when I write a program or design some hardware, I expect it not to work. And I'm almost always right. You know, so part of what I have to do is just make it work. I have to debug. I count on that. I can actually remember the times in my career when it did work. There was one time where I wrote actually 2,000 lines of code, connected it to another person at work who had written 2,000 lines of code. So we started debugging, we started running tests, and it actually worked. And I still remember it. That actually happened 15 years ago. And it was so shocking that I still remember. I was like, what do you mean there are no bugs? It's unprecedented. Okay, so it means that's really unusual. You have to count on debugging. So don't be frustrated. Don't think, you know, why doesn't this work? It's the way things go. So for software, debugging and testing typically take 50% of the development time. So there's a reference here if you want to go look that up. It's actually been growing. So this number is from 1990. It's probably higher now. One of my PhD students and I just wrote a paper where we're developed a new debugging system for hardware, basically for digital hardware and FPGAs. And one of the studies we cite, which is more recent than this one, is that 51% of FPGA design time is debugging. Okay, so debugging is a big deal. It's not like an afterthought. It's actually the heart of the design process. It's not just for software. I just mentioned that we do it for hardware as well, like digital logic. You do it for integrated circuits. Your mechanic is doing it for cars. And you can imagine, okay, so you don't want to just say, oh, my program crashed. That's what I know, okay? Why did it crash? That's like you go take your car to the mechanic and the mechanic just says, okay, drive it. It looks okay to me, right? Or, oh, it looks like the wheel fell off. You have to be able to get under the hood and look at what's going on in more detail. So that's what we're going to be doing here. Other systems people debug, say wireless base stations and communication networks, they have to debug the software, they have to debug the hardware, they have to debug the antennas, the spectrum. As the systems get bigger, the debugging gets harder and harder or more complicated. So, you know, you need to develop skills in this area. Okay, and debugging is a learned skill. So you can learn to debug effectively. When I started my engineering career, in first year engineering, I still remember writing, you know, literally 20 line programs. They were very, very small, and I would stare at them for hours going, why don't you work, right? And just running it and looking at the output over and over again. It's not a very productive debugging approach. Wouldn't work for the size of programs I write right now, but you get better at it. And that's what you want to do in this course. The system you're debugging isn't magic. It can be complicated, so it can be more challenging to figure out what's going on, but it follows rules. You can understand it. And debugging can be very rewarding. So if you can find difficult bugs, you can make difficult systems, complex systems work. It's highly valued everywhere. It's one of my favorite questions for graduate students I'm recruiting. Tell me about a difficult debugging experience you had. If they haven't had a difficult debugging experience, something they had that was challenged to make work, it tells me they've never made a complicated system work. So that's not good. One of my interns, when I was at Altera, debugged actually one of the most difficult problems I've ever seen. It was actually due to servers at Nortel, which at the time was a big technology company that had memory problems in the server that was making our program crash in the middle of a huge optimization, and nobody else was crashing. He was able to debug not just, it wasn't actually our program. Without access to their computers, he was able to debug the memory system hardware of their computers and show that The problem was their computers, not our software. When he completed that, I got an email from another director in San Jose who basically said, please make Henry an immediate job offer, right? So debugging is valuable. Okay, so what are we going to do today? So we're going to talk about a few high-level approaches to debugging, specifically the infection model, the wolf fence algorithm, and the detective method. So some ways to just think about debugging and approach it systematically. And then we're going to go into a deep dive in debugging a milestone 1 function. So you can see in this course, how can you debug effectively? And if we have time, we'll use an online IDE to debug a simpler program that you haven't seen. So yeah, usually in your career, when you're debugging things, you do not understand the entire system. So that's actually part of becoming an effective debugger is how do you figure out enough information to fix the bug, even though you might not understand everything about the system. And that's what this team debugging activity is about. Okay, so let's talk about a few high-level models of debugging. So the infection model. This basically is just a statement that software systems are causal, as are many other systems. So earlier states lead to later states. That's all that it means. So when we have a faulty operation, so there's a bug in our code. Some subroutine does the wrong thing, and it produces a wrong output. So our program has many variables, lots of state, but a little bit of it is now wrong because that subroutine had a bug. But we may not notice that right away. But because we've got some bad state, some variables wrong, the infection or the bad state can spread throughout the program. So other variables now get the wrong value because they depended on this earlier one. And at some point in the future, you get an observed failure. So maybe the program crashes, maybe you print out the wrong output. If you're lucky, the easier cases are you observe the problem approximately when it happens. You know, that variable was the root cause. But often it's not. You know, the root cause really happened way back here, and it propagated down to this one. Okay, so that's one algorithm. Basically, the algorithm understanding that what you observe, that failure, may not be the root cause. You have to think of what earlier state corruption could have led to that problem. Okay, second algorithm to keep in your mind is called the wolf fence algorithm. So the analogy here is I want to find a wolf in Alaska. And let's see if I can get this to show maybe me. I want to find a wolf in Alaska. So I can make the wolf howl, or I can listen for the wolf howling, and I can figure out what side of a fence it's on. So I'm going to use basically repeated division of the state of Alaska to figure out where this wolf is. Okay, so I put a fence, I listen, I figured out it's in the western part. Put another fence, listen, I figured out it's in the northern part. Another fence, listen, figure out near the coast, and so on. I keep eliminating parts of the state until I'm down to a very small area, and I found my wolf. So the analogy in a program is you've got a big program, and you're just trying to eliminate large parts of it from consideration. Localize what part of the program do you really need to dig into? Because in a large program, you can't say, well, I'm just going to go read all the code. It would take you forever. So you have to try to eliminate large parts of the program quickly from consideration and zoom in on a smaller part. So, you know, how do we employ this? So let's say we observe a failure here. We need to figure out what was the root cause of that failure. So we might go back and look at all the variables that can impact this output. And we could check at some earlier point in time, are they all correct? Maybe these are our global variables in milestone 1. And we find, yeah, they are all correct. Okay, so we can eliminate all execution of the program up to here from consideration. All that's fine. We might also find, okay, well, you know what? These variables, it turns out they don't actually affect this one. Okay, if after that, in this limited amount of time, we know that they won't affect it, so they're gone too. So now we look at, okay, what variables were used we backtrack. What variables were used to compute this one? Because that one is wrong. We printed it out, it's the wrong answer. And maybe it's these two spots. These two variables affected it. And it turns out this variable was computed from these two. Well, we know those ones are correct. So we're now down to kind of two spots, two places in our code where the problem might have come. So we go and check both those. Turns out this variable is correct, but this is wrong. This is the root cause. Okay, that's the observed failure, but this one earlier is the root cause. Okay, the last kind of meta approach you want to keep in your mind is the detective or scientific method. So you're basically coming up with hypotheses based on your observations and then proving or disproving them in order to narrow down what is the bug. And you want to do this, you want to think of what hypotheses are reasonable and also which hypotheses can you test quickly, because that's going to affect how quickly you can get down to the root cause. Okay, so you observe. So you're going to observe by inspecting the program state. And that means you can look at standard output. So you look at what was printed to the screen. You can insert some more print statements. But you don't only want to do that. You also want to be able to observe variables in the debugger, because you are going to use print statements to debug. It's a valid technique. But in many cases, it's much slower than directly observing the program state in the debugger. There are cases where printing works well, but there are also cases where it's much less efficient. How many of you are using the debugger regularly? So let me quickly check this. Okay, I got one. Anybody else using the debugger regularly? Two, okay. Anybody else? 3, 4, 5. Okay, a few more using the debugger. So you want to get comfortable with the debugger. Not only will it make you more productive in this course, it's a key skill, right? It'll make you more productive through your whole career. Okay, so that's how we observe things. You observe for a while and you come up with a hypothesis. So maybe we observe there's a seg fault. Okay, so program crashes. And we know seg faults are often caused by going outside of an array or a vector's bounds. So given where the seg fault occurs, maybe we have a hypothesis that we're going out of bounds for an array called street segments. So if that's the case, we can make a prediction. We can say, okay, well, we can see there's a loop that goes through this. And at some point, we expect this loop counter I to go beyond the size of this vector. So now we need to test it. So we do an experiment. So we can run that exact case in the debugger. We can watch that I variable and we can see, does it go outside of the bounds or does it not? If it does, then we found our bug. And if it doesn't, we've disproved this. We need to come up with, need to observe some more, come up with a new hypothesis. Okay, so those are the high level approaches, but debugging is kind of a, as I said, it's a learned skill. There's some art to it. So you need to kind of dive into it and really do it to get good at it. So we're going to debug one of the M1 functions, and it's one that we wrote in tutorial 3. So 2 weeks ago, it's find street segments of intersection. So that takes an intersection ID, and that's passed into this function. So maybe we pass in intersection ID 232, and we're supposed to return a vector that has the IDs of all the street segments that are connected to it. So in this case, we return a vector with 3 numbers in it, and these would be the 3 numbers. Okay, so that's what we're supposed to do. We needed this function to be fast. So we stored some data in load map to make it faster. Specifically, we stored a 2-dimensional vector called it intersection street segments, and it basically stores all the answers. So the first dimension of that 2-dimensional vector was 1 entry for every single intersection in the city. So Toronto is about 150,000. So we have about 150,000 entries in this first dimension of the vector. And for every entry, what we actually store is another vector that has all the street segments for that that connect to that intersection. Okay, so this is intersection 1, and let's say it connects to 5 street segments. We would have 5 integers there that would give those 5 different street segments. Okay, so does that all sound familiar? Hopefully you remember that from a couple weeks ago and you've been coding it. So it's like, yeah, got it. Okay, so I'm not going to do that team debugging activity at this point. We're going to go do a demo. So let's see. Okay, so I'm, this is a milestone 1 solution. And it's only partly done. Let me show you what we got. So I'm in libstreetmap source m1.cpp. Okay, so this is the function that, let me shrink this down a bit. Whoops. Okay, let me show you this m1.cpp so you know what we're dealing with. Whoops. Okay. So we've got that global variable, intersection street segments. It's a two-dimensional vector. It's got a comment above it. I should probably put more information. So there's a comment saying this is a global variable. Okay, from a code style point of view, I should have more information. I should say exactly what this global variable is used for. This comment kind of tells me what all the global variables are for. I put a few kind of banners to separate my global variables from my helper functions, from my main functions, trying to get some good style marks for my TA. Andrew's my TA, is on the line. Andrew, hopefully you like this. Okay, and then I get into the function definitions. So load map basically just tries to load the streets database API that we gave you. If it doesn't work, it returns false. Otherwise, it calls this helper function to load this intersection, like these street segments of each intersection. And if that all works, it returns true. Let me ask you this. How many people's load map function is pretty long? So think about your load map function. Is it kind of long right now or not? So if it's pretty long, put your hand up. You can admit it. There's no shame. It hasn't been submitted yet. You can change it. Okay, what do you think of my load map function? I mean, I'm not done yet. Okay, so I haven't written all the functions, but does it look long? So this is how you keep your load map short. You have helper functions. So if you look at your load map function and it's like 80, 100 lines, it's got a whole bunch of loops in it, your TA is going to dock style marks. Okay, your TA is going to go, that's not very good. You should have had helper functions to keep this more organized and short. So write it like this. Okay, that's just a good habit to get into. If you wrote it with a long function, it's really easy to refactor. You take each of those blocks of code and you move them to a helper function and you call them. And and you can put a nice comment above that function. Looks a lot more structured. Okay, so that's what I did. So I'm making an argument that my code style was good here, and you could copy it. Okay, so I have this load intersection street segments, and it basically implements loading that two-dimensional vector that we talked about. Okay, I get the number of intersections, and then for every single intersection, I go through. Let me make sure I've got enough battery here. Okay, we'll see. For every single intersection, I go through, and one by one, I get the street segments that are connected to that intersection, and I put them in the appropriate vector. Okay, so that's what this function is doing. And again, we wrote it in tutorial 3. And then my function that actually gets called a lot, the one that's speed tested, find street segments of intersection. Okay, it gets passed in an intersection ID, and it just returns this pre-calculated vector. You ask for intersection 28, it returns the vector that goes with intersection 28. So just looks it up and returns it. Really simple, really fast. Okay, so hope this is familiar. We went through this in tutorial 3. Everything else is just stubbed out. Okay, I haven't actually written the rest of it. I've just written stub functions that return the right type, but not the right value so that it'll compile. So my close map doesn't actually do anything useful yet. Should clean up all my data, but it doesn't. And all my other functions just return the right type, but none of them are going to pass the test. Okay, they're all stubs. Okay, so let's go take a look at how this works. And I'm going to do this with command line. You can do it in the NetBeans IDE if you want. It's fine either way. So I'm going to clean up any build files so I know exactly what I got, and then I'm going to do make. Same as clicking the build button in NetBeans. Same, it'll do the exact same thing. Okay, so I just built my program, and now I'm going to run ece297 exercise. Okay, for milestone 1. This is going to produce a bunch of output, so I'm going to pipe it. I don't want it to scroll past too fast, so this is called the pipe symbol. It basically says take the output of it and send it to a program. The program I'm using called more. It'll show me the output one screen at a time. So it can be handy when lots of stuff's going to flow by. Okay, so hit enter, and it's going to run a whole bunch of tests. I know most of these are going to fail because I didn't actually write the functions. But the very first tester is for functionality for intersection related tests. And the function I wrote is actually an intersection related test. So it's inside there. And I get an error. So you can see I've got a failure in intersection street segments. Okay, so that's actually the function I wrote. This is the one I hope will work. And it says unhandled exception test crashed. Okay, so not good. Then I get a bunch more information. It says streets database is already loaded. Okay, I didn't actually write close map, so this shouldn't be too shocking. I never unload anything. And then I get a failure in intersection street names. So it basically says it expected unknown. We have some streets that we don't know their name. They're like highway on-ramps, they're back lanes, etc. We just give those a name of unknown. This test is saying we expected to get a street name of unknown, but we got an empty street name, like just nothing. When we called this find street names of intersection. Okay, that's not surprising. I didn't actually write that function. That function is just stubbed out. It just returns an empty vector. So I'm going to ignore this, right? This is just an expected failure. If I keep going, you'll see there's more expected failures. And I don't care, okay? So the rest of them I don't care about because I didn't write any of those functions. But I do care about the very first one. I'm going to I actually don't want to run all these tests over and over again because I know most of them are going to fail. I didn't actually write those functions yet. So all the scripts that we wrote in this course will give you help if you give them the option -H. So I just typed help for ece297 exercise. And you can see one of the options it takes is called list testers. Okay, so I'm going to say ece297 exercise -- list testers. Let's see, what did I do wrong? Oh, I forgot the milestone number. Okay, so it gave me the names of the testers. And I'm basically going to run, there was another option there called run tester. And I'm just going to put in quotes, just regular single quotes. I want to run any test that has func intersection in the name. So star matches any characters. So this means run anything with func intersection in the name, which is just going to be this first test. So I'm going to get less output. Okay, so I expect this to crash again. I'm just kind of cleaning up my output so I don't get so much stuff. So now it only ran, there are 3 tests inside that test suite. All 3 of them failed. One of them is, now 2 of them I expect to fail because I haven't written the function yet. But the very first one is, again, this intersection street segments, which crashed. And I didn't expect that because we actually wrote that. Okay, so what should I do? What's my next step? Should I post on Piazza saying I wrote a function and the function crashed? What should I do? Is that my next step? Andrew, what do you think? Are you going to answer that Piazza post?
It's going to be challenging to answer. It's very vague.
Yeah, so Andrew is saying, you might not have heard that, but he said that's a pretty challenging one to answer. Okay, so you're not going to get an answer to that. In your career, if you're asked to write some function and you go back to your boss saying, yeah, I tried to write it, but it just doesn't work. That's an extraordinarily vague bug report. Okay, no one can really help you with that. So we need to get more information. Fight the urge to just say, okay, so what should we do? Should we go stare at the code for a while? So we know the code crashes that is somehow related to this function that we're trying to get to work. So should we go stare at it? What do you think? Who votes for stare at the code? We could do that for the rest of the tutorial, right? So sometimes students will say, I've been staring at this code for 3 hours and I can't do anything. So we could spend the next half hour staring at the code. Would you like to do that? Or do you think maybe there's a better thing we could do? Everyone's looking at me blankly. They're like, I've already, in my mind, I'm already staring at the code, right? So we're not going to stare at the code. It's maybe, if it was really simple code and you just wrote it, maybe you go look at it quickly, right? You go, okay, it crashed. Maybe I don't need any more information. But usually this is not enough information to make much progress with. So what can we do to get more information? What are our tools? So any idea? What should I do next? I want to do things that are kind of easy so I can get more information quickly. Yeah, what do you think? Yeah, so I can use the debugger, and we're going to go there. Anything else we could do? So it's a perfectly valid thing to do. I'm just going to try it in a different order. So that's one of the two things that you should be thinking. There's another thing that could be useful too. The program crashed. Okay, so let's go back and look at what it said. Okay, so unhandled exception means, something horrible happened to this function. Okay, it didn't just get the wrong answer. It had something that caused the program to be killed. Okay, so it could be a divide by zero, could be a memory fault. Most commonly, it's a memory fault. So what can we do to get more information? So we did something bad. Like I said, it could be divide by zero, could be a memory fault, could be a few other things. Is there anything we can do to quickly try to narrow that down? What do you think? How would I do that? Okay, so go look at the data structure that's using. So I could do that. So I can start looking at the code. What I'm going to do before doing either of those two things, though, is I'm going to run the debug check build. Okay, so that was just running the regular release build. Fastest build, best for performance tests, but actually the worst for debugging. Okay, because it has, so for testing, my best build is actually, I'm going to get rid of my build results. So I do a make clean. And then I'm going to, and I can do this in NetBeans if I want to, but I'll do it here. So I'm going to do make configuration equals debug check. All right, so I'm rebuilding my program in debug check mode. Who remembers what debug check does? Somebody must remember. I believe you're shy. You're like, I'm in person. I don't know what to do. Yes. Yeah, it does a whole bunch of additional checking. So it's a lot like Valgrind. There's a few things that even Valgrind doesn't do. So every one of the container classes, vector, list, map, etc., it will check before it does the access if that entry exists. So it will also check all your memory accesses to see if you're going outside of the bounds of an array. So it does a whole bunch more checking on your program. It slows it down a lot. It's 10x or more slower than release, but it does a bunch more checking. Okay, so I can use the arrow keys to just go back to a previous command. So I'm going to go back to this command and run it again. And let's see what happens now. So running exercise on the same test case, but with a different build, debug check build. Okay, it's slower. So it's taking a lot longer to load the map. That's fine. That's expected. Okay, so it failed, and that makes sense. We expected the test to fail. So it's running these public functionality tests for intersections, and here's the first error message. Okay, so can anybody interpret this error message? So it's a better error message than just saying unhandled exception. Unhandled exception means something really bad happened, program can't continue. Now I've got a much better error message. What does this mean? Can anybody interpret this for me? Whoops, sorry, Andrew. Yeah, what do you think? Exactly. Okay, so I'm just going to repeat that in case you didn't hear it. So it says it's trying to access a vector. So this line, it says I'm in line 417 of a vector, the vector file inside the standard library. That's what this means. Okay, we don't know what line 417 is, and we don't really care too much, but tells us we're in vector. And it says you were trying to access something with index 1, and you're actually trying to use the square bracket operator. That's what subscript means. But the container only has one element. And for a vector, if you only have one element, that means element 0 exists, but element 1 doesn't exist. So it's an out of bounds error, trying to access something with the square bracket operator in a vector that does not exist. Okay, we don't know exactly where we were in our code when this happened, but we know that's happening. It tells us the memory address of the object in question. I can't really do much with this just by looking at it. In the debugger, I could actually say, show me what's at that memory address. Might be useful. And then you see that the exercise code basically says, okay, well, you halted with sig abort. So sig abort is program is being killed. It's being killed, and it says likely that's due to memory corruption, or maybe it was due to, yeah, it's likely due to memory corruption. But the key error is this new one. Okay, so it is indeed memory corruption. We're trying to access a vector outside of bounds. So that helps. We could now go look at our code, and we can look at it with a little more purpose. Look for square bracket operators on a vector. But we don't know which vector. So still we can do better. So I'm going to take the earlier suggestion, and we're going to go run this through the debugger. Okay, so let's go take a look at NetBeans. NetBeans gives you a graphical interface to a debugger called GDB. GDB is a very popular debugger. You can actually run it from the command line if you want as well, but most people will run it from NetBeans or Eclipse or another IDE. But that's what you're really interacting with, is that debugger. So let's see, what do we do here? I've just clicked on this little drop down, and this is all the build types. So debug check is and release. So I was just running at the command line. This just calls make. It's exactly the same as what I did at the command line. There are these other build types. So there's one called unit test release, unit test debug, unit test debug check. Let's select unit test release. Okay, so what unit test release does is it basically doesn't build your main program, like the program an end user would run, the mapper program. It's now going to build a test program, okay, called test libstreetmap. And where does it get the extra code to build that program? Well, it gets it from this test directory. So let's go look and see what's in there. We give you a couple of things in there. Okay, so this is example test.cpp. It's an example of a test, and you can read our unit test quick start guide to understand what is some of the syntax. It's just basically pre-written macros and functions that make it easier to create tests. This example test is really simple. It basically just says, I will always pass. Check if true is equal to true. Well, true is always equal to true, so this is a test that's always going to pass. And there's this tester main function. And this is actually now your main program when you build the unit test release or debug builds. And all it says is run all the tests. By convention, what tests do is they return the number of failed tests. So you capture the number of failed tests, and that's it. Okay, so let's say I build this right now. So I selected unit test release. I'm going to do a clean and build because I just switched build types. Okay, let's make this output window a bit bigger. And I'm going to run it. So press the green button to run it. There was only one test. I said it basically checks if true is equal to true, so it passed. Okay, so not super interesting, but it all worked. Okay, now I want to so I could go right to more tests in there if I wanted. So I can now write some tests for the my intersection street segments, but I don't feel like writing any tests. I just want to get the exact test I was failing. Yeah, go ahead. There are ways to do that. So one way you can do it is just get rid of all the tests you don't want to run. That's what I actually do. There is syntax in the unit test library to say run specific tests, but I don't remember what exactly it is. I know there's a Piazza post on it where someone asked and one of the TAs responded with, here's the code to do it. And the unit test library we're using is called unit test ++, and there's lots of documentation on it. So you can do it, but I'm just kind of lazy. I just delete all the tests I don't want and let it run them all. Okay, so I could write my own tests. Don't feel like it. I want to run the exact test that I was failing. So the tests that exercise is running are public. And on page 18 of the milestone 1 handout, it tells you where they are and how to get them. Okay, so I've read that. I know where they are. And it's in this directory. Basically, all of our public files are here. So it's into the public directory for this course, under tests for milestone 1. If I hit Control D, let's see. Why is that not doing it? Okay, I've actually managed to lose connectivity, I think. Oh, interesting. Okay, let's try that again. Okay, so I don't know how many, what I'm doing here as well is I'm hitting tab to complete file names and directory paths. So you can do that when you're typing commands. It can make long paths a lot easier. And you can hit Control D to see what are the options for files that you might enter. So that's what I'm doing here. I'm hitting, I don't remember actually all the names of this path. I just hit Tab and Control D to see what's there. Okay, so in this path, these are the files. And if I want to run the exercise unit tests through the debugger, I need to copy them over into my project so I can basically build them and run them through the debugger. So I need two things. I need this unit test util file. So I'm just going to copy it to dot, which is my current directory. Actually, let's make sure I go into the right spot. So let's change that. So I go to libstreetmap tests. Okay, so now I'm in the right spot, and I copy over the files from M1 tests, and there's this unit test util.h, copy that to dot, which is the current directory. Okay, so we need those utilities. I hit the up arrow to go back to that command so I can edit it again. And I also need this M1 functionality, M1 functionality intersection, Toronto. Okay, so that was the test that I was failing. So I'm going to copy that one as well. Okay, and if I do an ls, I can see I used to have two files. Now I've got 4. So let's go back to NetBeans. So in NetBeans, I can now see this test file. Okay, it's gray. Anybody know why it's gray? What does it mean in NetBeans when a file is gray? Yeah, it means it's read-only. So I can look at this, but I can't edit it. Now I copied it, so I can do anything I want to it. Like I can make it editable if I want, because I copied this to my own directory. But for now, it's read-only. I can't edit it. Okay, so what does it do? You don't really need to understand all the details. There's a bunch of setup code. Let's ignore that. This is the first test. Okay, so it says, and you can see its name matches the test that failed. So intersection street segments, this basically text fixture means a test, a set of tests. And what do these tests look like? Well, basically, I've got a vector of expected values. Okay, so expected is these 3 integers. And we're comparing that to the values that came back from my find street segments of intersection function when you called it with intersection ID 10. Okay, so we've already calculated, we know what the answer should be. It should be these 3 street segments. And if you give a different answer than that, it's not going to pass. Now we didn't specify in the header file what order you return these in, so we sort them. So no matter what order you return them in, you're going to pass the test. Okay, because we always sort the answer and we sort what you return so that it'll compare easily. But we failed this, right? When we ran this, we actually crashed. And there are a whole bunch of tests here. So for a bunch of different intersection, it checks, what street segments should you return for each case. So we can go down here. There's a whole bunch of those. Okay, then there's another test. This is intersection street names. I've only stubbed out that function, so I know I'm going to fail this one. And then there's a third test. Okay, after that, there's basically this are directly connected. So that's all these tests do. And then we get to the end of the file. Okay, so it's not actually a really complicated file. Okay, so I'm going to build this. I just made some changes. I brought some files in, so I should build this. And I'm going to run it. And it's going to run basically it's going to do what I got from ece297 exercise. So I run it, and I get a whole bunch of error messages. The most interesting one is the start one, because that's the one I wrote. And it's basically failed in intersection street segments, unhandled exception, test crashed. So exactly the same thing that exercise told me, right? I crashed in that function. But now I've got it inside NetBeans. Okay, so I'm going to actually get rid of the other 2 tests because I don't want to see all that extra output all the time. So I need to make this readable. And I can do that with the chmod command. So you can look it up online. How many people know what chmod is? Have you heard of that? So it's used for changing permissions. So I'm just going to make this file readable. This M1 func, I hit tab. Okay, so that file is now readable by me. And you see the gray is gone. Okay, so now I can edit this file. And I'm going to get rid of 2 of these tests because I only want Let's see where I stop here. Okay, so I just get rid of 2 of these tests by deleting them. I'm going to rebuild this. Run it. Okay, and now 1 out of 2 tests failed. And I got the same error message I had before. So the 2 tests are just this intersection street segment test that I keep failing, and that test that always pass test, right? That simple one. Okay, so I've got everything in NetBeans, and now I want to debug it. Okay, so unit test release, I don't want to use in the debugger because release build code has been reordered. It's more difficult to interpret what's going on. It does run faster, but it's harder to watch it in the debugger and understand it because it may operate in different order than you wrote it. So we don't want that. We're going to change it to debug. Could run unit test debug check, but I found that that one is less robust. The NetBeans integration of the debugger unfortunately has a few bugs, and the debug check build seems to have more problems with the debugger. So I recommend you use the unit test debug build instead. Okay, so I'm going to do a clean and build. So I rebuilt that. Okay, and now if I click on this green arrow, it just runs normally. I don't want that. I'm going to click on this one, which will run it through the debugger. Okay, so I'm running it through the debugger. It's going to run a bit slower, right? It's not optimized anymore. And let's see if I've got any breakpoints set. Okay, let's get rid of this breakpoint. Okay, so that's left over from before. Let me stop the debugging run, and we'll try it again. Okay, so I'm going to do that again because I don't want a breakpoint to start with. Okay, so I ran it. It crashed, and which is not surprising, right? I keep running this thing, it keeps crashing, right? So that's not a surprise. Can anybody interpret this and tell me what I should do next? So it says segv. Signals are basically, you're going to learn about them in 243, interrupts. Okay, so there's a signal from this program, and this particular signal means segmentation fault, which is bad. I tried to access memory that I do not own, and the operating system has killed my program because I'm a security threat. Okay, this is consistent with what debug check told us. Debug check said we're trying to access something outside the bounds of a vector. Turns out that access is even going outside of our program, so the operating system killed us. So that's what happened. What should I do? I got 3 buttons here. Any favorites for clicking on buttons? No idea? Okay, so my favorite is this one, discard and pause. Discard and pause basically says, okay, throw away the fact that I had a seg fault and let me look at the state of my program. My program's dead, but let me just look at the variables. So I'm going to click on discard and pause. And this shows me where I am. And I'm in a function I don't recognize. Whoops. Okay, so I'm going to plug in my PC really quickly because it looks like I might not make it through the lecture otherwise. All right, so you can think about this for a second. All right, so I don't recognize this function. But I can click on this call stack button. So I click on call stack and it shows me how to get here. Okay, so I can go, okay, I don't recognize that. Let's go up one, let's see what function called this. I don't recognize that either. That's still in the standard library. Let's click on this function. Okay, this one is actually inside vector and is pushed back. So I didn't write this, but at least I recognize it's pushed back. And click back one more level, and it tells me I'm in load intersection street segments, and I'm actually on this line. Okay, so you can see this line, that's where this little yellow thing is. Okay, so I now know where I died. I died in the loading, and I died on this exact line. I can actually examine the variables. So I was actually on intersection 1. Okay, so this lines up with what the debug check build told me. It told me that I was trying to access a vector with ID 1 or index 1, and it only had one element. So it was illegal. This is my problem line, and it's intersection 1 that's killing me. So I can now look at this, and maybe I can see what the problem is. But let's say I still can't figure it out. What I can do now is click this red button to stop the debugger, because I can't, the program's dead. I can only look at variables. I can't make it go forward or anything. So I'm going to stop it. I'm going to set a breakpoint by just clicking in the left margin. And now I'm going to debug it again. Okay, so now it's going to stop on this line when it hits it, and I can actually watch it execute. And this is kind of the final stage of really getting lots of information. So I'm now basically I've hit that breakpoint, and I can look at the number of intersections, for example. So if I highlight that, got 151,000 intersections. Okay, so intersection 1 should exist. It's there. And I can click on this variables window. And this shows me interesting variables that I might want to see. It's what the debugger thinks are interesting. And up here, I can click on this button. That's called step over. Anybody know what step over means? What does it mean? Yeah. So step over, I'll just repeat that. Step over goes one line forward. If that line is a function call, it won't go in the function call. It'll just go over it. Okay. There are also, you can go inside function calls if you want with other buttons, but I'm just going to step over. Okay. So step forward another line. So I'm here. Nothing's seems to have gone wrong so far. I'm into this for loop. Let's see. So this for loop, I'm at intersection 0. Okay. And let's just keep stepping through line by line and seeing what happens. So the number of segments at this intersection is 3. That seems reasonable. So that's the number of street segments. I get the first street segment, and its street segment ID was 0. That seems reasonable. Could be true. And I push that into the vector for intersection 0. And that seemed to work. Okay, let's keep going through. I go through this loop a couple more times. So I got street segment ID of 104. Then I got street segment ID of 121,000. These seem like reasonable numbers. They're okay. And I keep pushing them back into this vector for intersection 0, and it all seems okay. Okay, so I didn't see anything that really went wrong there. And let me get rid of this. Okay, let's just keep going through this. Okay, so now I've gone back up to the top of the loop, and I'm on intersection 1. Okay, so I'm going to go really carefully, because intersection 1 is where I have my problem. I know that from debug check and from when I looked at the call stack before. Okay, I get, for the number of segments at that intersection is 2. That seems okay. The street segment ID of the first one is 0. That seems okay. And now I'm about to put it in here. And let's see what happens. And we crashed. Okay, so that is exactly where we crash, on that line. I can go discard and pause again if I want. But my program's now dead. I can't go any further. If I type, I can actually type interesting things here. Well, let me run it one more time. And let's see. Okay, so let's see. So I came back here because I actually let the program die. I'm going to quickly step through till I get to intersection 1. Okay, so I'm on intersection 1 again. I'm about to access intersection 1 and try to add something to the vector that's there. And I'm going to type, let's see, where's my new watch button? I can actually look, I can type things like this. Intersection street segments dot size. So I want to know what the size of that first dimension of the intersections vector is, and it's 1. So there's only one element there. I'm going to try to access, ID index 1 and it's going to fail. Why? Now I need, that's basically lots of information. So the problem is this. Pushback only creates, I've basically done a pushback here, which created index 0 in this vector. I didn't create any other indices. And then I'm trying to access other indices with the square bracket operator, which is not allowed. Right? Square bracket operator doesn't create things. There is a pushback here, but this pushback is basically trying to grow the second dimension of the vector. It's not growing the first dimension. So the easy way to fix this is, if you actually remember the tutorial, we actually used a resize command for this. So we used a resize to basically create all the entries, one for every intersection, all at once for that vector. And now I don't need this. This is kind of useless because I'm not using it. Okay, so if I stop debugging and I rebuild and I run that, it now passes. Okay, so now the output is 2 tests passed. Okay, so that's how you debug unit tests. You follow this process, try the debug check build, copy the tests over, run them through the debugger, and try those experiments. Try to sort things out with hypotheses. We're not going to go through this team debugging activity, but if you want to practice debugging, you can go through the slides, go to this online IDE and look at it. Basically, this is an exercise in debugging a program where you don't understand the whole program. But it turns out you can use the wolf fence algorithm, the infection model, to debug it without understanding it all, which is a common approach. Okay, so that's all I have for today. And if you want to read more, here are a couple of references for systematic debugging. You're going to get lots of practice debugging in this and other courses, and treat it as you're developing a key skill, because that is what you're doing. Okay, thanks everybody.